This video will go over multiplication and division with complex numbers. This is the second video. The first one was on addition and subtraction with complex numbers. So what we want to do is start by doing the first three examples. Those show you how to multiply complex numbers. And then starting from number 4, we'll look at division. So if we look at the first example, we have basically we need to use the distributive property. And also we want to make sure that we write our answer in a plus bi, which is also known as standard form. So just using the distributive property, we're going to multiply, but we have to be careful. Just a reminder, when you multiply and you have a square root or any radical, and then we have something like 2i, we cannot multiply numbers that are not in the same place. And so since 5 is inside the square root and 2i is not inside of a square root, we can't multiply them together. The only thing we can do is just write 2i times the square root of 5. And then in this case, the second part, we can multiply these together because they are both outside of the radical. And so we get plus 4i squared. And then you need to remember that when you see I squared, you need to replace I squared with -1. And so I'm going to write this as 2i times the square root of 5 plus 4 times -1, and I can write this as -4 plus 2i square root of 5. And that is my final answer. This is in standard form. It's an a plus bi form. I just switched the two terms around, but I have my answer in the correct form. So the first one was distributive property. The second and the third, we're going to use FOIL, right? So the steps are the same. And so we're going to have 4 times 7, that's 28, minus 8i plus 21i minus 6i squared. We need to combine like terms, and we also need to replace I squared with a -1. So you need to make sure anytime you see I squared, you want to simplify it and replace it with a -1. So I'm going to write 28 and minus 6 times -1. I just brought this over here. And when we subtract those, we're going to get plus 13. And then from there, we are just going to combine, make that plus 6. And then from there, we're just going to add like terms, and that's going to give us 34 plus 13i. Next, we're going to FOIL. This problem contains a square root, so again, be careful how you multiply your numbers. I can multiply 2 times 4 because those are both outside of the square root. So that's going to give me 8 square root 3 plus, again, I can multiply 2 times 3i. I don't touch the square root because there's no other number in a square root. Just multiply the outside. So that's going to give us 6i times the square root of 3 plus 4i plus 3i squared. Okay, so we have 8 square root of 3. This problem's a little different compared to number 2. Number 2, we had like terms here. These two, they are not like terms, right? This has a square root, this doesn't. I cannot combine these together. I still need to replace I squared with negative 1. If I replace this with negative 1, this just becomes negative 3 plus, what I'm going to do is I can factor out I, okay, so I can just factor out that I, and I can write my answer this way. So this is actually in the form A plus BI. So A is all of this, B is all of the part inside of the parentheses. So this is a little bit longer, like when you look at the answer, because we weren't able to combine like terms. But then it's still in the same form. A plus BI. So for multiplication, we had those 3 examples. Let's take a look at division. So there are a few types of division problems. One of them has an I in the denominator. So this is just one term, right? So I have one term. If you just have one term and it contains I, all you have to do to simplify this, because we have to take this and we have to write it in the form A plus BI. Okay, so I need this, right? This is what we need. So how am I going to turn this division into something that looks like A plus BI or A minus BI? So what you have to do is you have to eliminate the imaginary, the I, from the denominator. The only way to do that is to go back to what we did before. You need to multiply this fraction by I over I. Okay, so I over I is 1. It doesn't change the value. 1 times anything will be that thing. So this doesn't change the value. But I know that I'm going to get I squared, and I squared is equivalent to negative 1. That will eliminate I in the denominator. Right? So replace I squared with a negative 1. And so I have negative 5I. And I need to put this in A plus BI form. So how do I do that? Well, the A part, right, the real part is 0. So I just write 0 minus 5I. Okay, so that's my final answer. So if you have a division problem and you have to change it to A plus BI form, standard form, you need to get rid of the imaginary part in the denominator. And we do that by multiplying by some form of 1. In this case, it was I over I. And this is an example where we just have one term in the denominator. Let's take a look at a few more examples. So example 5, same type of problem. We have division. You've got your imaginary part in the denominator. This is also still one term. So if you have one term, we're just going to follow the same process as the previous example. I am just going to multiply this by I over I. You can do 3I over 3I, but we don't need to do that. You really just need I over I. If you do 3I over 3I, you probably need to reduce somewhere. So let's just do I over I. It's just easier. We need to distribute in the numerator. Okay, so we get 3I minus 4I squared. And the denominator turns into 3I squared. This is what you want because I squared is really negative 1 and you've gotten rid of I in the denominator. So let's continue simplifying this. We have 3I. This turns into plus 4 because I have to replace I squared with a negative 1 divided by negative 3 again because I squared is negative 1. So now this is actually in the form A plus BI because what I'm going to do is write this as a fraction. Okay, so you can break this up into 2 fractions. So we have negative 4/3 minus 3I over 3. Okay, I just moved the negative up to the top. And 3 over 3 is actually 1. So we could really just write negative 4/3 minus I. And this is in the form A plus BI. So A is negative 4/3, B is negative 1. All right, so now example 6. This one's different compared to 5. Because if you look at the denominator, we have 2 terms, right? I have 5 and I have I. So that's 2 terms. This was just 1 term. Okay, so it's 2 terms because we have a subtraction sign between them. If you have 2 terms, you want to go back to thinking about conjugates, because that's going to eliminate I in the denominator. So in this case, we want to think about complex conjugates. Okay, so complex conjugate, I'm going to multiply. I still multiply just like number 5, but I have to multiply by the complex conjugate of the denominator. And so I'm going to multiply here by 5 plus I divided by 5 plus I. This is very similar to what we did when we were rationalizing the denominator. It's the same idea. When you FOIL the denominator here, you're going to eliminate the middle term, and the middle term is the one that contains I. So we distribute in the numerator. And FOIL in the denominator. And remember, the middle term will go away, as you see right now. Okay, so again, this will always happen. Middle term right here is 0. Will always happen when you multiply 2 conjugates together. And then we need to replace wherever you see I squared, we have to replace that with a negative 1. And it just basically changes the sign. So your numerator is now 10I minus 2. And right here, we're going to get 25 plus 1 because I've replaced I squared with negative 1. So, and we already have a negative here, so that turns into plus 1. So now we just need to do a little bit of simplification. I'm going to write this as negative 2 plus 10I. I just switched the order over 26. You got to put this in A plus BI form, and notice that you can reduce. So basically break this up into 2 fractions, and we're going to reduce each one. So this is my final answer, negative 1 over 13 plus 5 over 13I. You can put I in the numerator or in the middle of the fraction. You cannot put I in the denominator. That is our final answer. It's completely simplified and reduced. The last type of problem you'll see in this section is something that looks like this, where we have I raised to some exponent. So there are 2 possibilities. Your exponent is even, or your exponent is odd. Those are the only 2 possibilities. So what we're going to do is we have to simplify number 7 and number 8 because we have to put our answer in A plus BI form. Okay, so what I'm going to do is I'm going to go back to exponent rules. You can rewrite I to the 20th using I squared. Okay, I squared to what power? 2 times what is going to give me 20? 2 times 10. Remember exponent rules. If I have a situation like this, we use the power rule, which says we can multiply. So 2 times 10, that gets me back to I to the 20th. These are equivalent. Remember, I squared is equivalent to negative 1. So this is really negative 1 in parentheses to the 10th power. Well, -1 to an even exponent, like 10, is just going to be 1. So then we're done. However, we want to write our answer in a plus bi form. So I am just going to write plus 0i because the b part is 0. You can actually write any real number like this because for any real number, the b part is 0. Last example, if my exponent is odd, there's no way for me to write it like I did here because 2 doesn't go into 15. What you can do, however, is just subtract 1 off of this exponent. So I really have I to the 14th times I to the 1st. Remember your exponent rules. If you're multiplying with the same base, you can add your exponent. So this is equivalent to I to the 15th. For I to the 14th, I'm going to apply the same rule I applied for number 7. You're going to write I to the 14th as I squared to what power? What goes on the outside? 2 times what is 14? That would be 7 times I. I squared is -1 to the 7th times I. -1 to an odd power, like 7, is really -1. So this is really -I. Now, I need to make sure I put this in a plus bi form. So it's really 0 minus 1i, or I. Okay, so again, just quick reminder. This is an a plus bi form, a plus bi form.